Hey there and welcome. So I want you to take a look around you for just a second. Chances are you're in or near something made of concrete. It's literally the foundation of our world, from the sidewalks we walk on to the skyscrapers that shape our cities. We see it every single day, but we rarely stop to think about it, or more importantly, how it could be made so much better.
Because here's the thing. For all its incredible strength and reliability, our trusty old concrete has a couple of pretty big secret weaknesses. And, figuring out how to solve them is one of the biggest challenges in engineering today.
On the one hand, what we see is its amazing power, right? These gigantic, long-lasting structures. But behind the curtain, making all that cement releases a huge amount of CO2. And on the structural side, when you put it under enough tension, it cracks. So how in the world do you fix a problem that's basically baked into the DNA of our most essential building block?
But what if you could give it something like a muscular system? That's not a crazy metaphor. It's exactly what scientists are doing right now. They're embedding these tiny, tough fibers into the concrete, and it's creating a totally revolutionary new kind of material.
This stuff is called fiber-reinforced concrete, or FRC for short. And the idea is actually pretty simple, but it is a total game changer. You're essentially mixing in this web of small, super strong fibers that hold the concrete together from the inside. They stop tiny little microcracks from ever becoming big, catastrophic failures. It's all about making concrete tough, not just hard.
And we're not just talking about one type of fiber here. No way! It's more like a superhero team. You've got steel fibers, which are like the powerhouse, bringing that raw strength and physically bridging cracks. Then you have polypropylene. It's the specialist that improves the concrete's workability so it's easier to mix and pour, and it controls cracking while it dries. And then there's basalt, which, as researchers found, adds this incredible resilience and toughness. Each one has its own unique superpower.
And if one superhero is good, a whole team is way better, right? Well, that's exactly the idea behind these hybrid fiber systems. Researchers are literally creating a dream team by combining different fibers to get the best of all worlds. You get the strength of steel, the control of polypropylene, and the toughness of basalt, all working together.
And this is not just guesswork. Scientists are dialing in these recipes with incredible precision. For instance, some key research found that a specific blend, just 1% steel fibers, and a tiny fraction, just 0.1% of polypropylene fibers, gave this huge boost to the concrete's overall strength. See? It's all about finding that perfect, precise combination.
But hold on, because adding fibers is really only half the story. The other massive revolution is happening inside the concrete mix itself. We're talking about smarter and way greener recipes. So, scientists are adding things like microsilica and fly ash, which is basically a byproduct from burning coal, right into the mix. And this is where it gets really cool. This research shows these additives do three incredible things all at once. First, they reduce how much of that carbon-heavy cement you need. Second, that lowers the environmental footprint. And third, they actually make the final product even more durable. It's a true win-win-win.
Okay, now here's a twist that might sound a little backward at first. Engineers are also trying to make concrete lighter. By cutting down on a structure's own weight, what they call its self-weight, you reduce the load it has to carry. That means you can build taller, more efficient buildings using less material overall. It's just brilliant engineering.
And maybe the most exciting idea behind all of this innovation is the concept of turning our waste into a resource. This is about creating a real, honest-to-goodness circular economy for the entire construction industry.
The whole process is just genius in how simple it is. You start with industrial waste. We're talking steel from old tires, that fly ash we just mentioned, even crushed stone from old demolished buildings. That stuff gets processed into usable fibers or other materials, and then it gets mixed right into new concrete. The result? A structure that's not only stronger, but is literally built on a foundation of sustainability. And the research shows this absolutely works.
And this tech isn't just for brand new buildings. We can also use it to retrofit the buildings we already have. By wrapping beams and columns in these jackets of new, ultra-high-performance fiber-reinforced concrete, we can strengthen our aging infrastructure. This makes it last longer and helps us avoid the massive environmental cost of tearing everything down and starting from scratch.
So let's recap. We've got stronger fibers, we've got smarter chemical mixes, and we're using recycled materials. When you pull all these different threads together, what does the future of construction really start to look like?
Well, it's definitely not one single magic bullet.
Creating this super concrete is a truly multifaceted approach. It's all about optimizing those fiber combinations, maximizing the use of recycled materials, designing these advanced mixes, and engineering the whole thing to be as light and efficient as possible. Every single one of these elements has a crucial part to play.
So what's the big takeaway here? The next generation of concrete isn't just a small upgrade. It's a complete reinvention. It is fundamentally stronger, it's lighter, it's way more durable, and it's dramatically greener than the material that built the entire 20th century.
And that really leaves us with one final fascinating question. For the last century, concrete has been the symbol of industrial progress. But now, looking at all these innovations, you have to ask, can this reinforced, recycled, re-engineered material become the foundation for a truly sustainable future? Well, the research seems to be saying pretty loudly that it absolutely can. Thanks for joining this explainer.